oil and gas coming from comets, hydrocarbons on planets and moons from comets and asteroids, and they share biogenetic and maturation signatures with what we have on Earth. And if you see the video before this one concerning Immanuel Velikovsky's worlds in collision, this was one of his theories that he was so ridiculed about. He was saying that yes, oil and gas hydrocarbons come to us by comet impacts. And this is exactly what we found, not only comets, but also what we have in on Jupiter. And I'll read the article for you because that's, even though it's not new, most of us don't know of this. Hydrocarbons and their biogenetic origins. According to Explorer magazine, hydrocarbons in the comets and asteroids likely were formed like those on Earth, that is, biogenetically, according to AAPG member Prasanta Kuhopadhyaya. And yes, that's what he says, biogenetically, as in rising from life, in this case, extraterrestrial life. That's what he says. These hydrocarbons are coming from extraterrestrial life in the form of incoming celestial bodies. Now, this scientist likens meteorites known as carbonaceous chondrites, or CCs, and he says they're like cosmic dandelions spreading hydrocarbons and life-forming elements throughout our solar system. He says oil and gas hydrocarbons found on planets and moons may come from comets or asteroids and share biogenetic and maturation signatures with Earth source rocks. And according to him, from the standpoint of the presence of hydrocarbons and PAHs, polycyclic aromatic hydrocarbons, I believe he says that both life and hydrocarbons could be universally connected. He says the solar system's unconventional petroleum system could eventually provide fuel for space travelers and interplanetary colonists. I support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below. This is an artist's interpretation of one of the hydrocarbon pools of Jupiter, a NASA interpretation. Lakes of oil. So, going to NASA now. Titan's surface, organics surpass oil reserves on Earth. Titan's surface, organics have oil reserves more than what our Earth has. This is from NASA Jet Propulsion Laboratory Solar System Exploration. I'll leave the link below for you. And it's the artist's imagination of hydrocarbon pools, icy and rocky terrain on the surface of Saturn's largest moon, Titan, for example. Now, Saturn's orange moon, Titan, has hundreds of times, and Saturn is a planet that Immanuel Velikovsky was talking about, that Saturn and Mars had a collision. A part of the planet's collision had impacted our Earth, skimmed our Earth, and that's what caused floods and tides. And the moon changes, the solar system changes at the time of Moses and Exodus from Egypt, about 1500 BC, according to Velikovsky. So the Titan moon has hundreds of times more liquid hydrocarbons, according to NASA, than all the known oil and natural gas reserves on our Earth, according to this new data from NASA's Cassini spacecraft. The hydrocarbons rain from the sky, collecting in vast deposits that form lakes and dunes. The new findings from the study led by Ralph Lawrence, Cassini radar team member from the Johns Hopkins University Applied Physics Laboratory, Laurel, Maryland, are reported in the January 26 issue of the Geophysical Research Letters. And this is not new. This is the article is dated February 13, 2008. I'm sorry, I said Jupiter. It's Saturn's image. Okay, I'm sorry about that. So, Lawrence said, Titan is just covered in carbon-bearing material. It's a gigantic factory of organic chemicals. This vast carbon inventory is an important window into the geology and climate history of Titan, he said. At a balmy minus 179 degrees Celsius, that's minus 290 degrees Fahrenheit, Titan is a far cry from Earth. Instead of water, liquid hydrocarbons in the form of methane and ethane are present on the moon's surface, and tholins probably make up its dunes. The term tholins was coined by Carl Sagan in 1979 to describe the complex organic molecules at the heart of prebiotic chemistry. Cassini mapped about 20% of Titan's surface with radar. Several hundred lakes and seas have been observed, with each of several dozen estimated to contain more hydrocarbon liquid than Earth's oil and gas reserves. The dark dunes that run along the equator contain a volume of organic several hundred times larger than Earth's coal reserves. Proven reserves of natural gas on Earth total about 130 billion tons, enough to provide 300 times the amount of energy the entire United States uses annually for residential heating, cooling, and lighting. Dozens of Titan's lakes individually have the equivalent of at least this much energy in the form of methane and ethane. Lawrence said this global estimate is based mostly on views of the lakes in the northern polar regions. We have assumed the south might be similar, but we really don't know how much liquid is there. Cassini's radar has observed the South Polar region only once, and only 2 small lakes were visible. Future observations of that area are planned during Cassini's proposed extended mission. Scientists estimate that Titan's lake depth, by making some general assumptions based on lakes on Earth, they took the average area and depth of lakes on Earth, taking into account the nearby surroundings like mountains. On Earth, the lake depth is often 10 times less than the height of the nearby terrain. Lawrence says we also know that some lakes are more than 10 meters or so deep because they appear literally pitch black to the radar. If they were shallow, we'd see the bottom, and we don't. The question of how much liquid is on the surface is an important one because methane is a strong greenhouse gas on Titan as well as on Earth, but there is much more of it on Titan. If all the observed liquid on Titan is methane, it would only last a few million years because as methane escapes into Titan's atmosphere, it breaks down and escapes into space. If the methane were to run out, Titan could become much colder. Scientists believe that methane might be supplied to the atmosphere by venting from the interior in cryovolcanic eruptions. If so, the amount of methane and the temperature of Titan may have fluctuated dramatically in Titan's past. We are carbon-based life, and understanding how far along the chain of perplexity towards life that chemistry can go in an environment like Titan will be important in understanding the origins of life throughout the universe, said Lawrence. So this is by the Cassini-Huygens mission, the cooperative project of NASA and European Space Agency and the Italian Space Agency, a division of California Institute of Technology in Pasadena, Caltech, and the Cassini-Huygens mission for NASA Science Mission Directorate in Washington. And the Cassini orbiter was designed, developed, assembled at JPL, and this is according to NASA. So they say that it's the origin of life. Hydrocarbons being biogenetic, meaning bio coming from life, originating, being born of life. Amazing. Please leave your comments. Thank you for your support. So in other words, they found that recently, in 2008, the NASA article confirms what Emanuel Velikovsky was saying concerning oil and gas coming from asteroids and comets. So Velikovsky is proven right by NASA 30 years after his death. Please leave your comments, and thank you for your support.